Hi, I'm Rick.
Hi, I'm Oscar. Rick, we're going to talk about serverless because it is Serverless September.
Yes, the month in which we don't have to shut up about serverless, and we can talk about it for hours and hours and hours.
Yes. Well, we don't have hours and hours and hours today, so
No.
we're going to keep it in like 10 minutes.
Yeah.
We'll hope. We're going to talk about SQL Database Serverless.
Yes.
That's an offering in Azure at the moment. It is GA.
Yes, it is GA.
So let's run through it, because I think there are some scenarios where this will be a really interesting service to use.
I think so too. So let's dive into the slides. We have SQL Database Serverless, and in the end, what it is it's a compute tier that you choose for a single database. So you cannot choose it for instance, a pool. So a elastic pool will always have a provisioned throughput with the DTUs or the VCores, whichever you want to choose.
Yeah, that's already a specific efficiency model for a multi-tenant scenario or something.
True.
So I can imagine in that having hundreds of databases in an elastic pool, this model, there's always something going on there.
True. And of course, you want to have a generic level of availability of your databases. Whereas since this is SQL Serverless, or SQL Database Serverless, this automatically pauses your database if there's nothing happening, which means that you will have somewhat of a cold start actually getting it up and running again after it has been shut down. And that's something you don't want in an elastic pool.
Definitely not.
So there you have the basic level of performance that you would like for your database. And then with SQL Database Serverless, you get some cold start after a long inactivity period.
We have in the whole serverless, we see the discussion, and we see cold starts everywhere. We know how to go around it and the different models there. But in this case, we actually talk about pausing a database, which is really explicit. It's not like you go down to 0 hosts and therefore you might have a cold start. You have a paused database. You can see that in your database, I guess.
That's a good question. I think so. I do have a couple of databases running serverless, but I haven't checked what their status would be if they are actually paused.
Yeah, I would say after you use it for a while, you can definitely see where it has been paused, so that you can see if you have to tune your decisions
settings,
there.
the configuration. So talking about that one, you can have up to a maximum of 40 VCores running your database. So this is not for an elastic pool, but for one SQL Database Serverless. I have to get used to that. And then with the maximum of 40 VCores comes 120 gigabytes of memory. And the max of 4 terabytes of storage, in which I have to say that the memory is directly tied to the amount of VCores you specify.
Okay, so there's no separate slider for the amount of cores and memory.
No, but there is a separate slider for the amount of storage, with its minimum and maximum being determined by what you choose as far as cores go.
But for the storage, why would you put a maximum in there? Because it's only you're paying the storage, or just to limit yourself, maybe.
Maybe, but you only pay for what you use. So even if you specify 4 terabytes and you have half a gig in there. So that's actually a good question. And then what you pay is 0.0134 cents per VCore per second.
Euro cents?
Yes, euro cents. Yes, but actually...
in that scale, it makes a difference.
True, but also prices might vary based on the region that you're running your SQL database in.
Okay.
So keep that in mind.
I haven't seen that before in any service, did I?
No, but here they explicitly say, look at the region where your database is hosted, because it might have or make a difference in the price.
Okay, interesting.
And then the first line is actually very important. If you look at what you configure for a SQL Database Serverless, what you configure is you configure the minimum amount of cores you would like it to use and the max. So those two are tied together. So if you choose the lowest vmin, which is half a core, then you can have, I think, up to 4 cores as a max. But if you choose, for instance, 40 cores as a max, then the minimum is always 5. So those two are related to each other.
There's a specific bandwidth where you can play with.
Yes, and then the reason for this is not so much the first bullet on the lower list, because that one actually says whenever your load is between min and max, you pay what you use.
Mm-hmm.
So if you have min and max 1 to 4 and your load is at 2, you pay 2. If your load is at 3, you pay 3.
Mm-hmm.
And you do that on a per second basis.
Okay, so they're asking from you to have a good guess on where you're at.
Yep.
I can also imagine to make it efficient in the background to host these things for you.
Yes, true. But then the next
There's
bullet...
the sweet spot
yes.
for your...
Yeah, but then the next bullet is also very important, because if you configure a minimum of, let's say, 4 cores,
mm-hmm.
and your database is running and it's consuming 2 cores for like 2 hours,
yeah.
you'll pay the minimum you configured. So you're paying the 4.
Yeah. But they are available in standby, like we're used
yes.
to in a normal service
yeah.
tier. Okay, so that's interesting.
Yeah. When your database is paused, you actually have no compute costs, so
mm-hmm.
nothing. You do have a storage cost, which is equal to the provisioned compute tier from SQL Database in Azure.
Okay. That's just a normal linear scale.
Yeah.
But that's interesting, because then there is a gap there. It's like between using over your minimum,
yep.
and then using it under your minimum, because somewhere in there it needs to decide if it's going to pause or not.
Not entirely, because it's only pausing when there's no activity whatsoever.
Okay, so it's always the minimum unless you have, for a certain amount of time, you have nothing.
Yeah, true. So if we jump ahead one slide,
mm-hmm.
Well, we talked about the minimum and maximum VCores, but then if you look at the auto-pause delay, that defines the period of time the database must be inactive, which is completely inactive,
mm-hmm.
before it's actually automatically paused. And then it is resumed when the next login or activity on the database happens. Auto-pausing, by the way, can also be disabled, which I think is very nice, because then you still have the power of scaling it automatically between your vmin and vmax.
Mm-hmm.
However, you can never really go down to 0 because you disable the auto-pausing.
Yeah, it could be an interesting scenario, because maybe you just have this 1 week or this one moment that you're still using this because you weren't popular yet, but now you don't want to be confronted with cold starts because in a different time zone they're all of a sudden using your service.
True.
So that's a nice toggle to have.
But then you still have the automatic scaling of performance for your database based on what you configure as a min and a max. And then if we look at this from a graphic perspective, then there's a couple of things here that are happening. So the first one is the blue line,
mm-hmm.
and the blue line is the minimum amount of cores you specified for this specific database.
Mm-hmm.
So that's at 1. Which means, if you look at the orange line, from 8 to 9 approximately, the usage of your VCores is below that 1. But still, that's the location where you're paying for the 1 minimum VCore you specified,
mm-hmm.
because you have a minimum of 1. Then, as soon as it goes between 1 and 4, you can see the automatic scaling, or at least the automatic billing of how much you have used. That's actually what you bill, because the green lines is what's being billed based on the usage of your database, with the yellow line being at 4 for being the max. But then again, between 5 in the evening and approximately 10 p.m., you see that usage is under 1 core, but according to the green lines, as you can see with the green lines, the build number of VCores will still be 1 since it's the minimum.
Yeah.
Okay, then we have the first red rectangle that actually states, okay, so there's no more VCores being used here, there's nothing happening in the database, I'm still up and running, but I am inactive. And then what you set up in your auto pause is, after this amount of inactivity, shut it down completely. And then the minimum amount of time for that is 1 hour. So as you can see here, the first rectangle, there's 1 hour of complete inactivity in the database. Mm-hmm. So the second red rectangle, database paused, no compute costs, only storage because your database is not up and running. And then the person here that started working at 4:30 approximately gets the first hit, because then usage of the number of VCores is going up again. Yeah. That means we have a cold start to the database restart.
So it has had a slow first call. Plus that the whole 4 o'clock block until 5 is being built on minimum.
Yes. Yeah, from 5 to 10, sorry. That's being billed at the minimum.
Yeah.
So where the orange line goes under the blue line of the minimum amount, of course, but there is still some activity, so you pay the VMin there.
Yeah. So that is interesting because this might sound really good if you have like a 1 query an hour, but it doesn't. Because you will be built at your minimum, and then
it will stay active.
Need the pause feature actually.
True.
So I think you need to be careful when using this, because it's not cost efficient if you're not using the full model in most services like this. Then you might be better off with a more traditional version or just the auto scale function.
Yeah, or maybe have a look at do you have multiple databases with similar usage statistics
to
and
combine
put
them in a pool.
Yeah.
So there are a lot of features, but I think for some scenarios this is really cost efficient.
Yeah.
With peak loads once a month or all year long even. Like just keep it offline until we do that 1 time a year app spin up, and you don't have to deprovision it, because sometimes I am telling to customers like just redeploy it when you
and
when
especially
you need it,
with
if those kinds of cases,
and especially with something like infrastructure as code.
Yeah,
just push the button again, it will be back. But yeah, this also has its scenarios where it's really valid, and I can also see this working as, for instance, a database in a dev or test environment. If you have testers that are not constantly hitting the database, this might be a decent scenario to enable them. Yeah,
maybe you have your dev environment and your testers in your team, but next to that, I'm working on a project where we have we call it the hacking as a service. We have an external company like once a month going into there for a few days, and we need a separated environment. And for this, that would save up a lot of cost, because we want to provision something that works and it works fast and a bit like the normal app. And it's doing nothing, like most of these DBs are doing nothing there.
True.
The rest of the month. So interesting.
So looking at the scenarios, Microsoft themselves say, so serverless is really price performance optimized for single databases.
Mm-hmm.
And that's important. Serverless is for single databases. So you can have 10 serverless databases, but each of them is a single SQL database serverless database.
Server, what is it? Yeah.
Whatever. So that's really good for intermittent and unpredictable usage. But if you want to have price performance optimized for single databases or multiple databases with elastic pools or with higher average usage, then probably it would be a better reason or a better scenario to choose, for instance, elastic pools.
Cool.
So if we look at what serverless has over provisioned, we can see that, for instance, what we talked about earlier, the database usage pattern is intermittent and unpredictable for the serverless ones, whereas provisioned compute is better suited for regular usage patterns. But as you can see right here, I'm not going to read out all of them, but as you can see here, Microsoft is actually trying to give you the right tools to make the decision if a database needs to be in a provisioned tier or in a serverless compute tier. And they know that one has pros and cons over the other, and they try to give you all the tools you need to actually get the right choice in place. Now, looking at SQL Database Serverless by the numbers, the latency for auto-resume, so for waking up your database after it has been paused, is in the order of 1 minute. And if you have a web application with a cold start and a database with a cold start, then the first person in the office in the morning gets 2 of them.
You get a really big chain of cold starts, and you probably will have timeouts there.
But chances are that nobody starts before point in time X. So why not do point in time X minus 10 minutes and have a function app triggering everything for the first time for that day, making sure your database is up and running, your cold start of your web app is
You might
going.
even have the user in the front end already starting something up or going through a logging process, and you already have control of a redirect there. You can already kick an API call off to just warm this up.
Yeah, but that's things that you need to take into account as soon as you start working with these kinds of technologies. You need to make sure that you enable your users to use it in the best way possible.
Yeah, so you might need some tricks for you to like these edge cases that happen once a day or 2 times a day. If it happens more, you're probably in the wrong scenario or you tuned it incorrectly.
Yeah, true.
Really be careful with that, because otherwise it might be more expensive than just using the one we know.
True. And then to finish off with the numbers, if you auto pause, that goes somewhere between 1 to 10 minutes, because there's probably all kinds of optimizations around the process. Auto pausing is for a minimum inactivity period of 1 hour. So you need to have at least 1 hour inactivity before they even enable you to pause your database or your database to be paused.
Yeah, you're paying for the hour anyway. So
yeah. And then the max is 7 days. So if you really have a workload that spans multiple days, but also as soon as it's done, nothing happens for like 2 months.
Yeah,
that's even a scenario that you could.
Yeah, or like a couple of days a month and then nothing.
Yeah.
Like your hour sheets or whatever. You can think of a lot of scenarios that really will be helped with savings on cost.
True.
Talking about the cost, indeed, it's all VCore based.
Yeah.
Minimum 1. So that's.
Well, this is a example of costs. The minimum of the amount of VCores is a half.
A half VCore?
Yeah.
They're virtual, so why not?
Half a VCore. And then the absolute max is 40.
Yeah.
However, this is just an example of how to calculate the costs.
Yeah, just connected to the graph we saw earlier.
Yeah. So if you have a 1 VCore on minimum and 4 for max, and you auto pause it for after 6 hours, then if it's active the first 2, you'll at least pay minimum for
8.
Yeah, for the entire long period. So looking at that here in this table, you could see, so the first hour we have 4 VCores. That actually amounts to 1,400 VCore seconds in this, 14,000 VCore seconds. And then the second hour we have less cores but more memory used. So that's also, in this case, 14,000 VCores. But then look at the amount of VCores you're paying for the 6 hours of inactivity. But you specified 1 as a minimum and 6-hour inactivity period before shutting the database down. That means that you have 21,000 VCore seconds paid for a period of 6 hours in which nothing is happening. So of the entire costs, almost half is an inactivity period.
Yeah.
So we need to make really sure that the inactivity period is as short as possible within the constraints of the application where it's running.
But the good scenario to also start using this is to get insight in this, because you don't know upfront.
Completely true.
Especially for new cases, if you build something new, like you don't know what's happening, what's going to happen. And in this case, you have so many details and so many tweaks you can do.
True.
It's really nice to start off like this, because if it's not as successful as you hoped, then at least the pricing model is beneficial.
Yeah, true, true. So if you look at this, we've got just over 50K VCore minutes. VCore seconds. This would, in total, with 1 hour in which we use 4 cores each second, 4 cores, and 9 gigs. And the second hour, 1 core, but 12 gigs also every second. What do you think the total cost of running a database like that would be?
For a month or for a day?
For this day, for these 24 hours.
10 euros or something?
Nah, 6.75 €.
And that is pretty good workload.
Yeah, for the usage you're doing on the first 2 hours, that's not too shabby.
Yeah.
Okay, so there are some gotchas. And one of them is that occasionally load balancing can occur. Of course, because you're scaling, and it might be that the machine you're on doesn't have the cores available that you're actually trying to scale to. And then you'll have to do some load balancing, and then you're moving, and then. But then the cool thing is, I read this line, and then it says, okay, so for example, if the resource demand is 4, but you only have 2 available, then we do some load balancing for a couple of minutes until we are somewhere where we have the 4 VCores available.
Yeah.
And you will just be provided and the database remains online during the load balancing. That's awesome.
That's magic.
But except for a brief period of time at the end of the operation, because then you're probably actually shifting to the different
You need
location.
to move your connections.
So although we're already developing cloud native software with the fact in mind that we have to take into account that we are going to fail, chances of a SQL database connection failing in serverless are just a bit higher if you're doing a lot of switching up and down.
In the beginning, starting to use Azure SQL Database, that was the thing, like prepare to be disconnected. And you're stacking so many different services, building in the cloud with so many different SLAs. You need to build your software to be scalable, and that means it needs to be idempotent. And I think we should have this trick under control. But indeed, it's a good gotcha because in real life, the current solutions are pretty stable.
And I'm pretty sure that I can name a couple of solutions at least that don't use, for instance, Poly for storing stuff in their database. They're just either storing it or throwing an error.
Yeah.
I think it is either way important to make sure that we do this correctly, especially when we're running SQL Database Serverless. Then chances that you're being load balanced, and that means that you've got dropped connections, might just be that little bit higher. Now, there's another gotcha, and that's actually a list of stuff that if your database uses any of these, you cannot do auto pause. So if you have geo-replication or long-term backup or syncing it using it SQL Data Sync or using it as the job database in Elastic Jobs, it will not pause.
Okay, because the connections are used in the background somewhere.
Yeah. So
the geo-replication is a big job in the background, just syncing everything, of course. Yeah.
And so it has to have a connection to the database to see if anything has changed. So
but it's good to have these lists because if you're like, oh, let's use this, and then you're finding this out on the go, also your calculation is wrong.
Yes.
So, yeah.
Yes, if you're expecting it to be down 80% of the time and it's just running because of one of these, that might be a big thing.
Good to know.
So
Thank you.
that's it as far as the gotchas and the SQL Database Serverless goes. It's only one of now many serverless options that are available in Azure and in cloud solutions anywhere, actually. And we hope to see you soon.
Thank you, Rick.
Thanks.
See you next time.
Bye-bye.
Bye-bye.